What is going on? We are building modules. So this is the last time I'm going to try this video. At least I hope anyways for tonight. Audacity crapped out on me twice. I restarted my machine and plugged my audio codec into a real port rather than a hub. So hopefully this will work. Fingers crossed. Alright. I am here to show you the Logic Crusher, which is a module that I have worked on. Me and Derek have been working on for a couple months now, and I'm kind of stoked on some of the sounds that it can make. So before we start, I want to talk about just a really quick intro to how digital things work, digital, analog. So everything in a synth is traditionally, the actual interface you're dealing with is analog, right? You use these little jacky things and pluggy things. You plug it all together, and it's all just some continuous signal somewhere in between negative 12 volts and plus 12 volts. And that's used for CV. And if it goes really fast up and down, you can use it for audio as well. And I want to quickly go over how a digital signal works. So when you discretize a signal, so a signal on a computer, it's not continuous like that. It contains bits basically. It's either 0 or 1. So, and the quality of the bits is called the bit depth. So most audio interfaces are 21 bits. So really high, really good quality type thing. And at that point, it's almost indistinguishable between analog and digital. Rather from a record and from a CD or whatever. I guess there's people that can do it, but I'm not one of those people. So what I'm doing, what the Logic Crusher does is it goes from the analog domain to the digital domain, and then back to the analog domain. And in between, it's exposed in the digital domain in a form of wires. So there's 4 wires on the output, 4 wires on the input, and that will basically, you can do things in between, and you can get kind of interesting results. Now, quickly, how digital works is we have our bit depth is 4 with this module, so that means that there's 4 bits, and each bit can be 1 or 0, so a standard binary counting sequence goes like this. This continues 0, 1, 0, 0. This represents 0, 1, 2, 3, 4, until we get 1, 1, 1, 1, which represents 15. Or 16, I can't remember. Bit 0, bit 1, bit 2, bit 3. And those are exposed on my breadboard here as literal wires. So I want to show you what that actually means. So we got a VCO here. Let's just play this guy. So sine wave, huge. So what that looks like on the scope is this. It's your run-of-the-mill sine wave, nothing special about it. But what I'm going to do is I'm going to patch that guy into the Logic Crusher and show you the output. So we've gone from a continuous waveform. So basically we have the sine wave, and then we're going into the Logic Crusher. This is being exposed as 4 wires here, and I'm just jumping the wires across, because basically how it works is you have 4 outputs, 1, 2, 3, 4. Your analog goes to that, it gets converted to zeros and ones, and then 4 inputs, 1, 2, 3, 4. And that's kind of how I have it arranged on this breadboard. So I'm just jumping these wires across, so output equals input. And so you get this discretized signal of these different steps, and it's going to end up sounding a lot grungier. So the reason why you get that sound is because you have crazy harmonics all over the place, because rather than just having your fundamental I don't even know if you could hear me over that. The reason why you have that is because you have harmonics. You don't just have a fundamental frequency at your frequency of oscillation. You have the fundamental frequency of what you have, and then you have all these like wings all over the place, and those things are oscillating like crazy and giving you higher frequencies and all this crap all over the place. And I think that sounds really cool. So you can do, let me set this up so we can visualize and hear at the same time. I'm going to try to not talk when the oscillator is going, because I don't know if you can hear me or not. Okay, so that should boo. Yeah, there we go. That looks like it's working. And I want to be able to look at this thing as well. So there's something funny that's going on, and it's not perfectly wired perfectly because there should be 16 steps, and it looks like there's only 8. Anyways, so I'm going to try to do something. As I said, these wires here are, I've dropped the wires down so you can connect them. So right now they're connected straight across, sine wave in, you get a sine wave out. Sine wave-ish. It's a little dirtier. Yeah, there's something weird going on. It's not set up perfectly, but it's good enough for now. So let's switch the bit order. I'm going to jump some things across differently, and it's going to make a different looking waveform. So that thing looks pretty fucking crazy. Let's see what it sounds like. Sounds pretty crazy. And when you start changing these things like that, you get even more advanced harmonics than we saw before just with the straight discretized signal. So here I have some logic gates. So the way that logic gates work is there's hundreds of different types of them. You have AND gates. So what that means is if two of the inputs are both 1, the output's going to be 1. And if either of the inputs is 0, the output's going to be 0. You have OR gates, meaning if either of the inputs are 1, then the output's going to be 1. NOR gates, or XOR gates, exclusive OR, NAND gates, counters. You have a huge amount of chips at your disposal that you can now take this signal and do insane things to. And they're really cheap. They're like $1 each. So my vision is, so like the idea is in the future, people won't have to actually do a breadboard like this. You'll just buy a module. It'll have all these gates on it. And it'll just kind of like put a graphic on it so it's like descriptive of what's going on. And then you just take these little wires, do your little micro patch, make some sort of crazy ass sound, and then link that all together with the bigger cables. So I'm just going to quickly check the data sheet for these parts because I didn't check before, and now I want to show. Okay, that's what I thought this part was. So this first one is a hex inverter. So what that means is if the input's 0, the output's 1. If the input's 1, the output's 0. So I'm going to jumper some of these wires over here. I'm going to put that into the input. I'm going to get another wire. And then I'm going to jump that to the output of the hex inverter over to the other side. So this has made some crazy thing that I've never seen before. What the hell is that thing? I don't know what that is. I wonder what it sounds like. Whoa, what the fuck? So sometimes when you get really high frequency stuff, you just want to lower the frequency so you're not like into these high frequency dog areas where all the dogs in your neighborhood get pissed off. I'm going to start adding some other waveforms from my VCO. So that already sounds pretty. That sounds like hell, in the best possible way. So I'm going to change. I'm actually going to run this thing, and I'm just going to screw around with the wires and see what I can get it to sound like. So that's that weird fucking thing that I built. Everything we do is open source. Go check it out. Thanks.